In this video, we'll be talking about the period of the sinusoid. A periodic function is a function in which the values of the dependent variable repeat at regular intervals. Sinusoids are periodic functions since the values of y repeat every 360 degrees or 2 pi radians. This 360 degrees or 2 pi radians is called the period of the sinusoid. Note, a phase angle or a phase shift does not change the period of the function. So let's compare the graphs of these three equations. First, our basic graph, y equals sine x. Our period, if we start at the origin here, our period is the amount of degrees or radians that it takes to get from this point to the next identical point, which means I need to be heading back up on my curve. So I could trace, and if I keep going to the right, this is half of the period because I just do the top part of the sine curve, and then the rest of it, the other half, ends at 360. And notice that after 360 degrees, I'm heading back up, so this part of the graph is identical to this part of the graph. So our period for the basic sine curve is 360 degrees. Let me sketch that graph here. And it repeats, going left and going right. I'm going to keep this curve showing for a little bit so that you compare the two. So sine 2x now notice that from this point to this point was one period for our basic sine curve, but I get two curves done in that usual 360. Let me turn off the first one that I had so that it'll be a little more clear. So my trace, again we're starting at 0, and then going to the right, you can see that 180 degrees is my period for this one. So I'll try to line up my 180 here. Everything else is still the same. So this time I get one complete curve done in 180 degrees. let's look at my y equals sine 1/2 x. I'm going to clear these out. And I'll use 0.5 for 1/2. This time you'll see that if we start at the origin and go to the 360, I'm only getting that half a curve done. So if I use my trace key, I'll see that my period for this one, y equals sine 1/2 x, is actually 720. Yep, there it is. So there's my 180 and my 360. This would be 540. So I got only half of my curve done in the 360. So for this one, my period was 360 degrees. For this one, my period was 180 degrees. And for this one, my period was 720. So we can use this coefficient of the argument to tell how many curves are being done in the normal 360 degrees. But there is a formula that'll help us, and it's useful because it's not always so easy to see how many curves we have done. So our formula is period is equal to 360 degrees divided by b. So this is something that you want to remember. If you're working in radians, you'll use this one. Period is equal to 360 over b, and since my period on this one was 360, my b is equal to 1. So b is this coefficient right there in front of the x. And this one, period, which is 180, is equal to 360 over b. If we solve for b, multiply both sides by b, this will cancel, and I have 180b equals 360, and then divide both sides by 180. That gives me b is equal to 2, which we saw right there. And then do the same thing here. My period, which is 720, is equal to 360 divided by b. Again, multiply both sides by b to get it out of the denominator. And we have 720b equals 360. and then divide both sides by 720. And we see that b is equal to 1/2, which is what we had right here.